So let's continue our event. In this session in the afternoon, we will start from a successful story from an external company who decided to join our project. Then we will talk about the Greek pilot, and we will close with a roundtable discussion about what comes next after the project ends. So together with me, we have Matthias Perano, data scientist from Dive, and Marie-Claude Belda, sales director. Dive, they will introduce the company, but they were implementing in the same substation of the Spanish pilot a proof of concept about a similar technology. What we did in the pilot. Actually, they have their own product that was running, that is actually running using GPU, and they found our approach interesting, our approach in virtualization. So they joined the project, and now they are here to tell more about their experience. Thank you.
Many thanks. So yes, so first of all, many thanks to the organizer of this event, and we are very pleased to be here in Brussels, even if the weather is not that beautiful as we have in Madrid. So I'm Marie-Claude Belda, as Daniel said, and my colleague Matthias, and we're going to give you an overview of this project we jumped in, as Daniel mentioned. So first, we'll give you an introduction of our company, who we are. Then our solution, and precisely the solution of computer vision that has been used in the project that Matthias on the third part will talk about, give more information on the project. And then we took a small video, a demo, so you have an idea of the final result that we expected from the beginning. Okay, so our company, who we are. So DiveTech is a company that belongs to the group ISPD, which is a multinational Spanish media company, and Dive is the artificial intelligence branch of the company. Okay, so it's a company inside a group, and it's the artificial intelligence. We are present through ISPD in 7 countries. More than 25 years of experience, because the team is a team who has been involved in artificial intelligence since the beginning. That's like Obelix. We felt in the sauce when we were babies, right? So that's the reason why we have 25 years of experience in the artificial intelligence world. And we do produce and offer to the market innovative solutions such as the one we are going to present, and others as well. Okay, so we are really specialized in artificial intelligence, computer vision, and other solutions. ISPD is a group listed company. The ISPD group is listed in the Paris Euronext, so that's a matter of fact, and in Spain, which is our, even if I'm not Spanish, but that's, nobody's perfect. So in Spain, we are considered as a leader company because of the team that's built up this company, DiveTech. And for those who knows the KDD Cup, the team, again, it was not Dive at that time, it was another name of the company. The team won the KDD Cup in 2008, which was at that time a very, very renowned award for artificial intelligence in 2008. We did speak about artificial intelligence at that time. Okay? So we've given an extract of the customer. As you see, we work with large company, and we jumped on the project with Endesa as soon as we knew that there was the possibility of running this pilot. Okay, so our solution, what is it made of? So in the solution of computer vision, which is the one that we've used in this project. So we have a multi-camera tracking system, okay, which produces continuous monitorization and which is intended to send alarms of situations of risk in this case. Okay, so the computer vision platform that Matthias will explain afterwards is the one who has all those algorithms that run on and detect those situations. And what I have to say is that the computer vision solution see what the human eye is able to see. Okay, so and it sends in real time those alarms that are supposed and that are supporting the warning about the risk that is happening. So, as I was mentioning, that's the way it works. The big blocks of the big functional blocks of the solution. First, okay, there are the cameras. You will see the input that those cameras is receiving from all the area that we are monitoring. Then they go through the person and the pole detection model. So we have to understand in what the camera sees, where is the person, where is the pole. And then it goes through the transgression model. Then those people are doing things, and we have to detect when they go beyond a limit, which is supposed to be the limit of risk. Okay, so where the person is at risk. And then, and by the way, we have as an input all the configuration. You will see that with Matthias. That is, what's the place in the substation where the guy is safe, the person is safe, and where there is danger. Okay, so you will see that as well this part. So that configuration, together with the transgression model, as soon as there is risk, send an alarm. Okay, send an alarm, and I've been told, I have not seen that, I've been told that as soon as the alarm is validated, as soon as there is an alarm, there is a siren, a really strong sound that is going to be emitted. Wow, 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 you're in danger. Okay, so that's the way the system works. And regarding Smart5Grid platform, our understanding of what it's going to bring is something. I mean, we've summarized in three main elements, what it's going to bring to this world. So the first is the scalability, and this is such an important thing, that the system is always stable in terms of response time. Okay, so this scalability is one of the points, I would say, potentially the highest benefit of the platform. However, I mean, scalability, flexibility. However, we think as well that all the enhanced development and deployment platform, all those workflow that are intended to make the work easy for those developments and the deployment of those systems. And finally, and that's something, the third point that we see as an advantage is this point of having great user interfaces. So I've been for years in the market, and I'm still seeing as of today people deploying application on command line. And that's something that I would love to see disappear. And I think that with that kind of platforms, we will see this happen. So now I'm going to hand the microphone and that to my colleague Matthias.
Hey, thank you. Okay, perfect. So, what is our solution about? In the Spanish substation, we have several cameras that send the data to the video recorder, high vision video recorder, and this is connected to the 5G network through the CPE, and in the other side we have the vRAN server that allows the communication to the Kubernetes cluster, that is where our application is deployed, through the neutron switch. There is also a siren connected directly to the CPE that is communicating with our application and is notified when some transgression is triggered. Okay. We have developed a small YOLO model using quantization techniques to speed up the inference process, and it is modified to detect the operators, the workers, and also the tools that they use. We have deployed this model with the OpenVINO framework that because the server where the application runs doesn't have any GPU, so we need this framework because it has a specialized software for running optimized inferences in Intel CPUs. Okay, our solution allows to flexibly define and create secure and insecure areas, so you can it can adapt easily to the new substations or new jobs, and thus to scale up easily. Okay, once we have the areas defined, the system uses this configuration to start detecting if the worker transgresses, leaves some secure area, and then notify the siren, to alarm the workers. To do that, the system collects all the data from the different cameras and collapses all that data in just one point, that is the position of the worker. This position is mapped from the 3D world to the 2D plane, and then the smart detection logic is applied in addition with the pre-configured areas. And all this process is prepared for run in parallel, so we can track several workers at the same time. Okay, we provide an intuitive dashboard that notifies immediately to the safety officers when an insecure transgression is made, so they can act quickly. This dashboard permits the option to monitor the whole substation, or to allow some areas, some zones when a job is to be done. Additionally, it allows to define new jobs and to assign to them new secure or insecure areas as desired. And finally, it saves all the transgression records into a database for further data analytics processes. And yeah, now my partner is going to tell you about them.
So, a short demo, please. Can you put the... So this is the system, the 7 cameras that we get the information from, and we combine the information covering all the operation area. You see, you are going to see now, there is the red line is the one that represents the transgression. Okay, so we are monitoring those 2 guys, and this is the map where we see if there is a transgression or no. Look, the red one on the map is not on transgression. The green one, yes, it is. So you can imagine where the transgression areas are, where they cannot go. Okay, now they are all both safe. So that's the map. And as soon as there is a transgression, and we put that in the alarm is sent over the 5G network to the queue that we see here. Okay, so that's the alarm that are produced. And those same, and it's not very, you cannot read it, but that was just to show that those alarms that were produced when the transgression occurred are sent to a dashboard as well, which is the same as the one that Matthias was mentioning before. So you can manage those alerts. So that's the 40-second video of the pilot with those cameras and these systems, which is intended to monitor the safety of those workers and all that over the 5G network, which is a great example and a great pilot, by the way, for us. And one of the reasons why, as well, we jumped into this application, this pilot with our colleague our colleagues was, of course, there was the interest, the technical interest of going to this platform. There's all that stuff, but there was another point, which is the security of the people, which is in the DNA of the company. Security of the people, security of the planet, and security of the business, which is in the end our mission in this world. So thank you very much. If you have questions, we are here and happy to answer. So that's it. Thank you.
Thank you very much to joining us, not only the project, but also today this presentation. And let's move ahead with the last pilot. We will describe the Greek pilot. Actually, it's a cross-border pilot between Greece and Bulgaria. I have with me Dimitrios Brodimas from IPTO, and also Michalis will be also with us from OTE, the Greek telco operator. Thank you.
Thank you very much. Great. Hello, everyone. I'm Dimitrios Brodimas from IPTO. I believe it's better here to showcase. I'm going to present you use case 4 of Smart5Grid, which concerns the real-time wide area monitoring in a cross-border scenario that took place between Greece and Bulgaria, as you can see there in Thessaloniki and Blagoevgrad. All right, great. So regarding the business goal of the use case, as you all know, the integration of the renewable energy resources implement issues in the reliability and the security of the actual transmission grid. Okay, so what we need is a real-time wide area monitoring framework that will monitor and enable the control of the energy grid. This will contribute with information and strategies to the actual power system operators. And how we do that, which is the actual objective, with a creation of a tool, a WAM tool, that consists of a virtual phasor data concentrator, a VPDC, a phasor measurement unit, two actually, one in each city, the PMUs, and a 5G communication network. Okay, and this is a map from the NSOE that indicates where exactly the PMUs are located and where the edge server hosting the application is. Okay, but what exactly are the phasor measurement units? They are a kind of IoT device that measures the phasors of the voltage and the current, that timestamps the measurements with GPS signals, and it provides those measurements with an FPS of 50 frames. Okay. It is based on the two protocols. The VPDC is created according to the protocol C37244, and the communication protocol between the PMUs and the VPDC is the 37118. And this is how the actual transmission grid operates right now. We have the interconnected systems of Greece and Bulgaria, the PMUs on top of the actual power grid that sends the measurements to the concentrators. We begin from a regional layer, then move on to the hierarchy until we reach the SCADA system and a common control room that could be from a regional security coordinator, okay? And this is the actual path. Okay, it doesn't show up very good here, but you can see with the red arrows the path of the information and the latency inserted in the actual system, okay? Because each concentrator introduces almost 40 or maybe 80 milliseconds of latency in each step. So in order to enable, okay, for monitoring we are good, but for control and to enable the control, we need something else. And this is the introduction from this project of the VPDC system that will interconnects right now, actually, the two PMUs in Thessaloniki and Blagoevgrad of the interconnected systems of the two countries directly and providing the information to the common control room to perform any analytics needed, okay? So, this is what we bring to the table, a direct communication between the two PMUs that we are interested in with the concentrator using 5G networks that offers better KPIs, that reaches the KPIs in a better way than the previous generations of communications, of wireless communications, and in comparison with the optical fiber, it is less costly, okay? So, the target market, because we use the PMUs, which are directly engaged with the energy consumption, okay, the energy loads, and the power exchanges, it is, the solution is directly affects only the energy market, okay? So the customers could be TSOs, DSOs, and RSCs. For the opportunity, this is a virtualized framework that could enable the fast fault detection in the total part of the energy grid, ensuring its stability and ceaseless operation. Now, this is the architecture that we implemented. Again, the interconnected systems, the two PMUs, using 5G gateways in order to connect to the actual communication networks, the commercial communication networks of the two major operators of Greece and Bulgaria, in order to pass the measurements from the PMUs to the NetApp, to the network application that consists of three services: the VPDC, the advisory services that analyzes the measurements and forwards some guidelines to the two TSOs, and the monitoring service for the operator of the grid to check that everything is okay. We used the nearby one orchestrator in order to deploy those applications, and of course the OSR and the VMV frameworks developed during the course of the project, provided by Axon, UbiWare, and Atos, in order to facilitate this deployment. And now some things for the services. The VPDC, as I already mentioned, is a concentrator. It gathers, aligns, and of course synchronizes, and then forwards the measurements to the next level of hierarchy. And it uses the certain protocols that I already mentioned. The monitoring service, which provides several status indicators of the grid. And the advisory service that informs the TSOs if something goes wrong with the power grid. Here are some UIs of our network application with the phasors from the two lines that are currently monitored, and one screenshot from the PMU in Bulgaria regarding the voltage. Here is also a view of the substation in Thessaloniki. You can see the 400 kilovolt lines that reside above the PMU and the gateway. And here is a picture of from inside of the substation with the PMU, the gateway, and the GPS antenna that the PMU uses to timestamp the measurements. and how it is connected. Okay, this photo is from the early deployment of the PMUs and the Zixel, so no security concerns here. All right, and here's the network setup. The PMU is directly connected with an Ethernet to the gateway, and from there we used 3 different SIM cards in order to utilize 3 different scenarios of network in order to transmit the measurements. And now for the actual scenarios, I'm passing the floor to my colleague Michalis.
Thank you, Dimitri. Okay. Hello, I'm Michalis Rantopoulos. I work for OT group of companies for many years now. More particularly, my background is telecommunications. Having worked for almost 20 years for Cosmote Mobile Networks, which is now acquired by OT. So all references from now on will be as OT in our scenario. This is a high-level description of our network setup, highlighting on the interconnection between Greece and Bulgaria wide area monitoring. On the left part of the figure, you see the interconnected systems, the power grid line, the 2 PMUs at Thessaloniki substation and Blagoevgrad. The Greek demo and both demos utilize 5G non-standalone networks. However, the Greek demo encounters the international carriers challenge, as we'll see later, which has a great effect on the performance criteria. All the measurements from the PMUs are finally concentrated to the edge cloud servers based at Sofia, as you can see on the right part down of this figure. The Bulgarian side of the demo, it's relatively straightforward. You see the PMU broadcasts readings to the 5G gateway. The 5G new radio obtains those measurements and forwards them to the server gateway, which in turn forwards the data to the corporate packet gateway of Vivacoms. Then through a tunnel, this data are forwarded to the Vivacom cloud router and hence reach the cloud edge server, as Dimitris denoted previously. Now, for the Greek side of the demo, we, let's say, invented 2 different interconnection scenarios. The first one is utilizing the 5G standalone commercial agreements between Cosmote and Vivacom by means of a Vivacom 5G SIM card installed at IPTO's substation gateway router. What happens in this scenario, in order not to lose our focus, is that the serving gateway of OTE's network forwards the data to the packet gateway of Vivacoms. Now, this part utilizes the international carriers, which cause an excessive delay in our final latency criterion. We'll see in the real readings later why this happens. The other interconnection scenario is, as we call it, private APN, utilizes a Cosmote 5G SIM card and forwards the data from Cosmote's serving gateway directly to Cosmote's packet gateway, which is based in Athens, and this travel path follows the packet gateway path to Vivacom's router. This has slightly better performance than the previous scenario, since, as we have seen, it's not about the international carriers that utilized, but through the public internet, through an IPsec tunnel constructed. For the evaluation of the network performance of the overall performance of our use case, we invented the term field platform validation matrix, which is a hyperset of the KPIs, which have been earlier defined during the earlier deliverables, and consists of a series or a combination of core KPIs or application KPIs, which we chose according to what we wanted to describe in our scenario better. Very briefly, the metric network latency is measured through the Zabbix server. We don't have to go into too much details on this. It is a purely network-related metric. The PMU VPDC scheme latency is measured on the application part, as well as the application VPDC packet loss, and field FPVMs denoted communication network availability and reliability, are measured again by the network side. Now, regarding the validation of the KPIs, regarding the network latency, the Blagoevgrad PMU is within the absolute wait time criteria of 40 milliseconds. So it is considered as successfully reaching this target. The Thessaloniki, through the roaming scenario, exceeds this criterion, which is attributed to the excessive delay caused by the international carriers. The user plane path follows a path from Athens to Central Europe in Germany, where the IPX network forwards the data and then reach the edge cloud server in Sofia. This is unavoidable for such a scenario, which causes this excessive amount of delay. For the private APN, it's slightly better, the performance. However, it's still more than 40 milliseconds. A similar approach is observed for the PMU VPDC latency metric, where Blagoevgrad again is within the 40 millisecond criteria. The Thessaloniki roaming criteria has even more delay measured at 61 milliseconds, and Thessaloniki private APN 54 milliseconds. These are average values observed. And the network availability, in any case, is considered as very well for all scenarios. Network availability means the overall time the network was up and running. However, it has to be stated here that the network could be out of, let's call it, could be out of service for any reason. It could be for a trivial reason, such as a cable unplugged at the Zyxel router. This is an exercise that we perform by relaxing the constraint of the more 40 millisecond criteria, which has an obvious effect on the overall performance measured. You can see from 40 milliseconds to 45 milliseconds, and from the roaming scenario, the application packet loss drops from 100% to 54.42%, and for the private APN, from 100% to 49.43%. And even if this criteria is relaxed more, it drops to 7.65% for the private APN scenario. So this gives us an indication that such a setup, even with the burden of the interconnection scenario, could be used for a more relaxed absolute wait time criteria, for a less demanding use case. These are the observations from both sides of the demos and some lessons learned. We have measured that there is no significant delay inside Cosmote's mobile network in the RAN side and transmission side until the data reaches the serving gateway server. However, all the delay is attributed to the GRX interconnection side, as we said during this presentation. The Bulgarian demo has very good results because the data are handled, let's say, locally with a clear better performance of latency. And comparing the two scenarios for the Greek side, the Vivacom SIM card and the Cosmotes SIM card, the scenario with the Cosmotes SIM card performs better, slightly better than the roaming scenario. Conclusions? Okay.
Okay, even though we were given the Comsa photograph here, I believe that our pilot was more than successful because the actual add-on of such a demo was to perform a large-scale trial. So even the bad results are good results in order for the power transmission operators to understand what exactly they can exploit from the 5G technology and what not, okay? So the large-scale field trial was implemented in a cross-border scenario with two remote and advanced demo sites in each country that engaged the two major telco and the two major power system operators of both countries and facing several technical challenges during the whole implementation. The solution combined the next generation networks with edge computing and virtualization in order to implement the trials. It could support some time-critical applications of the power grid, such as secondary control. And, of course, it could support monitoring and the IoT and the communications of the IoT devices in the last mile of the energy grid. Of course, the OSR and the VMV and NAC provide an out-of-the-box deployment pipeline for the energy sector and not only. And of course, the solution is also comes with decreased cost as no dedicated hardware and costly deployments of fiber optics was used. Okay. So, as a final conclusion is that such a solution could promote the synergy of the fiber optics and the 5G technologies, since the fiber optics consists of the backbone of the smart grids, implementing a high bandwidth and actually reliable means of communication, and the 5G extends this connectivity, the highly reliable connectivity, to remote and mobile devices. Thank you very much.
Thank you. Thank you. Yeah, just the last consideration together with you guys is that, this Comsa, it was just for fun, but for me, it's not 100, but 200% successful pilot. The problem is that when we go to cross-border implementation, we need to deal with the infrastructure. So it's again, in the morning we saw that there is a lack of investment in the infrastructure of telecommunication. One of the pain points in certain regions, it's really the country-to-country interconnection that it's announced that since the highway was planned to go in the Northern Europe and then back to Southern Europe, it's a nonsense. So as a recommendation from this pilot or as a learning is that maybe some investment are needed in the region to enlarge the connectivity and fostering implementation of such technology for cross-border purposes. Okay, thank you, and let's continue with our set of slides. So actually, we don't have a set of slides, but more roundtable. So during the course of the day, we went through let's say a storytelling starting from energy field and what is the need in terms of virtualization and digitalization, because smart grids and energy application reached the point that without a reliable data layer and data and telecommunication layer, they can't make the quantic jump to move to a next level. But at the same time, we have lack of infrastructure or lack of sustainability. But let's exit from this kind of infrastructural question, and let's move back to the meaning. Why 5G? This morning we touched the topic of APIs, so I wanted to give the microphone to my colleague Andres from i2CAT to tell us something more about APIs and how is the scenario. Thank you.
Should I go in front or should I go? Exactly. I think, okay, it's better to... Okay. Okay. Good afternoon, everyone. For some may don't know me, my name is Andres from i2CAT. Today I'm going to explain why 5G. So yesterday we had a little bit discussion regarding why to evolve from 4G to 5G. Even in the most of the cases, 4G enables the same performance and same characteristics that currently we have in the 5G. But in the 5G, we have some aspects that maybe is not well known by all of us, but they can bring to the next level of the networking. So in that sense, one of the main aspects is that the 5G, in a sense, can enable the virtualization of the services. Because in 4G, the implementation of the core is like a black box that has several functionalities that can allow the control plane and the data plane can manage in a good manner in order to send the data traffic of the operators. But in the 5G, we have a clear separation between those planes, and they allows to the operator to distribute these functionalities along the network, along the cloud, and even we can put close to the end user. That is the reason of the edge computing that we are explaining here in the project. But it's not just that side regarding the performing of the 5G networks. It's just only the KPIs that allows to have peak data traffic in the 5G with ultra low latency and so on, but also enables other kinds of features. Like in 5G, we can enable as a isolation of the traffic in native wave. This is the slicing side. So in most of the use cases, we can see how could work the slicing. That is the reason that the 5G can bring to the next level in order to allow several use cases to coexist in the same network, but with specific characteristics, with customized characteristics. So this is important for us in order to define and design applications, like all of the applications that we are presenting here, that can coexist in a big ecosystem. But giving one step more is, okay, we have all of these applications presented by several partners like Dive, all of the solutions like Sidroco that we saw. So how can these applications can take advantage of the networking provided by the operators? So at the beginning, the developers just focus on how to deploy and define the services like an end service deployed in the cloud, whatever part of the internet, and the end user can access to that service, maybe by the operators and networking, or maybe by the internet providers. But now the thing is how these applications can react according to the necessities of the end users. In this case, should be the grid side, for example. So in that sense, how to customize these applications is important, because the customization shouldn't be static, should be dynamic according to even the networking performance, and also even the scenarios of the ecosystem, or even for the necessities itself of the end user. The end user can require different kinds of necessities depending on the time and so on. So in order to allow this to the developers and the end users to customize their requirements, the operators now, they are providing new kinds of services. They are opening the services of the 5G to the end users or to the developers. They are exposing their solutions with APIs. This is important. At the beginning of today's session, we see that the Wintry partner, they present how the APIs can be exposed. This is the one step, the 5G core. All of the functionalities can define some APIs that can be consumed by developers or applications. But this is the one side. The the application developers must know how this API works, but it sometimes could be complex. Now, JSMI, based together with Linux Foundation, they are providing and presenting a new project that they call Camara. So the idea is, okay, we have several APIs that the developers can consume in order to provide specific applications. So in that sense, they are presenting a standardized applications in order to the developers can consume specific parts of the networks provided by the operators, and also the infrastructure provided by the operators. So that is the reason that now, okay, the application developers, from one side, they have the specific business vision in order to provide specific services, but also they can consume the information provided by the operators. This information is exposed through these APIs, and also these developers does not take care if they are going to provide, for example, these services in a specific operator. They can provide these services through around the world, because that is the idea. These APIs should be standardized around the world in order to expand the service wherever the location they want to provide. This is easy, and they can consume the same services around the world. So this is the next step that here we didn't touch this part of the 5G, but this is the next step, and all of the efforts are moving on this part. And the applications that this concept that we present today, or during this project, the network applications, is going to move forward in that side. So the first side is just to standardize the way how to define the applications itself, and the next step is how these applications can consume the networking provided by the operators. So that is the reason that why 5G.
Okay, thank you, Andres. Just one consideration from my side, that this morning with Helio, we saw a schematic representation of the network application as a mean to simplify the complexity. So this was a deep dive on the complexity. And for those developers who are not aware about the specific implementation of that API, because, okay, API, it's the name of the interface, but I don't have a clue about how many parameters has to be configured to access that specific API for one functionalities. Maybe there is a need of more, some more functionalities or APIs to be combined together. And in this sense, the approach of network application is provided a single microservice, a single VNF to, for example, build a slice manager in a simplified way, so that the consumer of the API or the developer could use it to boost and foster the implementation of API. So it's one pro for the NetApp in a way that either you have the deep knowledge about this domain, or you need to find it in a market, or in case of a network application, combine it within your bigger scale application. One more point that we were not touching this morning, that it's part of the architecture of the virtualization, is the orchestration. I don't know, Angelos, if you want to spend. I know that it was without pre-notice. Surprise. A few words about orchestration. Like this morning, I tried to give some nuance about the potential, but it's not about staying here 2 hours. Just your point of view on this.
No, yeah, it's true that you made the first attempt to introduce orchestration, because orchestration was not here in all this presentation. We focused on use cases. Actually, we had many challenges during the whole process, because we were in the middle of different worlds, different partners. So we had the network part, we had the energy part, we had also the network development part where we had the most interaction with. Smart grid for us is a very interesting use case. So now verticals has a very, everyone talks about verticals. There are different domains, and smart grid is one of the most important. This project was a very good opportunity to get familiar with the different involved parties, different stakeholders, and yes,
Just let me give an example of if I have a wish book about the smart grid of the future. We saw in the fast animation about the system automation how the grid can adjust according to the evolution of a fault. But sometimes it can happen that during a fault, the antenna is not supplied by energy. And that's a big problem. So the power of orchestration, in case the distributed computational power, it's really implemented on field, the power of orchestration is to replace within zero time that specific edge node with some other edge node or some central cloud. And for me, it's really mind-blowing.
Yeah, I didn't want also to go and I didn't want to go that much into technical detail, because it's true. Yeah. And this is just one use case, and then we have the edge cloud continuum. We have resources from the edge to the cloud. All this distributed nature now we have, all this dynamicity about one example is what Daniele mentioned, but still all these applications are expected to be like new network, new application, new services, and they also require scaling, migrations. If we go to use case like use case 4, we also have the cross-border part where you need also to orchestrate things among different countries, and there are now like new initiatives like Camara in this world. No, there are many use cases. Now these are a few. We don't even mention about AI. So it's the potential is infinite. It's like
yeah, as I meant, we have too many knowledge domain, and maybe we were having this pre-assumption that orchestration is there, but we were not exploiting during this presentation. Thank you for the surprise contribution. Thank you. So, next volunteer, Nicola. Lord. I know that it will look quite weird, but Nicola has been pre-notified by email yesterday.
Oh yeah, what a surprise.
No, let's talk about Edge. So we had a specific implementation in the Italian pilot because, we were not entering in technical details, but it's maybe right to focus in what you did to interconnect a private network within a public infrastructure.
Yes, thank you. Thank you, Daniele. Hello again, everyone. For the few who may not know me, I am Nicola Di Pietro. I work for Hewlett-Packard Enterprise. And within HP, with the Athonet business unit, our experience is on core networking, mobile networks, 4G, and now, of course, 5G, and who knows what comes next. So when we talk about the edge, there are three things that comes to my mind, right? The edge services, the edge infrastructure, and the edge architecture. So I will try to approach this from top down. Edge services. What we have understood today is that there are advanced, even business-to-business services that make sense at the edge where they are. Let's think of use case 2. All the data that the cameras are capturing and which is being analyzed doesn't need to travel way further than the actual site where the security system is deployed. If we think of use case 1, in which we were also more involved, it is important that data is analyzed locally and that potentially only few useful information is forwarded remotely, and so on and so forth. So we are showing already that there exists the need to be efficient, to be computationally powerful and connectively equipped at the edge. Edge services. So for this, we need an edge infrastructure. So we need a mobile network, in our case, architecture, which is, edge architecture, which is capable of keeping data local. We do not need, just for architectural reasons, to send data to a centralized point somewhere in the mobile operator's architecture network, and then take it back to the edge from where it came. If my WhatsApp message travels to, I don't know, Amsterdam, we're already in a capital, so let's pick another one, and then comes back to reach one of our phones, not really a big deal. But if this really happens for all the data we handle for business-to-business services, can be a problem. So we need to enable this, and 5G, with its flexibility, Angelos briefly mentioned it too, allows for that. And then we need the edge infrastructure, which means that we need physically servers, devices, virtualization layer that can handle all of this, that can easily allow for deployment of applications and services, for updates in terms of scalability or in terms of complexity or modification of the topology of the network and so on. So I think that we have shown that all of this innovation can work and that can be exploited. And to conclude on exactly use case 1, as you mentioned, the very happy result, at least for what concerns HP, but hopefully for all the partners, was to show that we as a technological ecosystem, we can handle this kind of multi-vendor deployments in which certain components are deployed at the edge of mobile network operators' infrastructures like Win3 to enable the services that we have mentioned. This, as Daniele mentioned, falls well into the framework of what now it's called a public network integrated non-public network. So dedicated resources of a public network that are made available for private services. And as such, it also brings with itself a business model for it. Possibly answering to some of the graphs that your colleague showed us today, with the margin for making money out of mobile networks is decreasing. So let's find new ways to exploit it. So yeah, in this sense, I think use case 1 was a very good result, as well as all the others, by the way.
Thank you. Next question, Mark. It's you mentioned private network. Your expertise is also in private 5G infrastructures. So what's the picture on that? Because we talk about public infrastructure, and 5G introduces also a model for private infrastructure, maybe for the so-called e-industry or the migration. So Can you tell us something more
Yes.
about that?
Yeah, absolutely. So one of the great things that are coexisting with 5G, it's the fact that technology allows now both to deploy standalone, independent 5G networks that then can be used for private purposes in the same way or similarly to what sometimes we do with Wi-Fi. I mean, that's private networking, right? But now with all the features of 5G too. So this is one deployment model, a fully standalone network that serves some customers' private purposes. And we do not have to necessarily think of Wi-Fi examples. It can be bigger examples, but still private, like, I don't know, serving the connectivity of an airport, all the employees of an airport, several thousands, which may benefit from mobile network technologies more than Wi-Fi. So this kind of the deployment exists. And then we have what I mentioned before, the integration of private networks with a public, bigger, if you can say so, infrastructure into a combined deployment mode. And the great thing is that now technology is making this feasible, because we have, I mean, compared to, I don't know, 10 or 15 years ago, we have all the virtualization that comes to help. We can have very compact solutions, not to make too much of an advertisement of this moment, but HPE develops certain 5G, we call them tactical solutions that fit into a backpack, and they can just be carried out to give connectivity to firemen or police teams and so on. And this is really, I mean, goes a little bit further than the use cases we mentioned, but shows the fact that then it's just a matter of having enough fantasy to pick a good way to deploy all of this.
Yeah, of course. And if we put together the capability of the architecture to be flexible with the capability of the software to be handled remotely, I think it's adding some pieces of at the puzzle. We had an experience in private network in the substation for use case number 2, where we implemented 2 use cases in the same physical private infrastructure. We were struggling to have a connectivity with the rest of the world, because usually power plants are in the middle of nowhere or in area where it's not sustainable to bring yeah, I mean, there are areas where the substation are built that are not served. The same for windmills. Not necessarily they are served by 5G. So combining private 5G facility with optical fiber and other technology will allow more flexibility. And the concept that is quite relevant for as a result from the project is that once you develop a software for this kind of architecture, can be used in, doesn't matter which one is the configuration of the architecture, but it's the same software. I think the friends from Diva can confirm that this is one of the point of interest, that in terms of scalability, it's just matter about, is there any public infrastructure there? No, okay, let's understand if we can install a private infrastructure and use the same software. Okay, you were prepared. I'll give you a 10. Okay, A+. Yes. So let's give the microphone to Ralitza. And we mentioned this morning the opportunity to foster scalability. So virtualization seems like the key for scalability.
Yeah, indeed. It's been presented in the morning, the challenges that the
energy sector transformation is putting in front of all the players connected to the grid. Just to mention the few that from distributed energy resource perspective, we see more and more renewables emerging geographically distributed. Very often they are small and they're interconnected in low or medium voltage. So the TSOs are literally blind of what's going on from the production point of view. On the other hand, we have the consumption changing with a lot of industries going electrical. We have the consumption changing with a lot of consumers becoming prosumers. And this complexity really affects the way and puts a huge challenge to the grid operators to have visibility, predictability, and controllability over the network, over the grid. And on the other hand, the small size of the renewables makes it impossible versus the big renewable producers to get connected and be aware of what's going on. So improved visualization over the distributed energy resources, on one hand, gives the so needed visibility for the grid operators to understand what actually going on the network from the production point of view, and as a next step to forecast better the production flows, to control it as a next step, and to manage the stability of the grid. For the renewable energy producers and for distributors, having real-time monitoring over the performance of the asset is key for many reasons. Firstly, and immediately, it will allow them to at least manage the downtimes, in case of some fault, etc. And this is only the first step toward the next improved forecasting, improved availability to trade, electricity trading, improved operational maintenance, including some predictive maintenance. So having the application that is scalable, that is low cost, because when we talk about small distributed energy resources, it needs to be flexible, it needs to be easy to use, and it needs to be cost effective. So having such a solution will greatly improve both the grid management and the potential of the renewables to get integrated, to improve their operations, to manage the downtime, and even in the future, when the legislation allows, to take an active part into the flexibility exchange, for example, for providing demand response services to the grid, and managing congestions, etc. And yeah, improve visibility will help the grid operators to plan upon the investments, because that was another point that was mentioned. And if you are blind of what's going on, and if you don't have the data, the performance data, including the real time and the historical data, you cannot really plan upon, if you're a grid operator, of what's the best approach for improving or updating or upscaling the grid, so that it manages the resources in the most effective way.
Thank you. You centered the topic, because now there is the new grid code. It's already circulating. Some draft is already circulating. The new challenge is for example, the grid forming capability for inverters, and the topic is that if we talk about day ahead forecast, it's all about having some algorithm that it's correlating a series of information. But when you go in the operation, it's real time. So if the grid it's splitted and there is an island that has to be supported, a strong digital layer, again, I'm repeating myself, but a strong digital layer is needed to allow the grid operator to talk with the single, each and every production power plant to support this control islanding that in some region they are starting to talk about it. Maybe you are not ready for that, but you can profit from the learning
for sure.
from the others.
Plus, so the way we've developed the network application was that it makes it really easy for a third-party source to be connected, monitored, and even controlled. So this could be even a battery management system. So that's a kind of a flexibility service that could be requested and actually turned on immediately from a grid point of view whenever some congestion is expected. So being connected in real time, having real-time information, and as a second step, the controllability over the monitored asset is crucial and key for all the players on the energy grid value chain, and a critical step toward the smart grid of the future.
Okay, thank you.
Thank you.
So this morning we also mentioned something about several projects in 5G PPP. We have next volunteer. I hope you studied.
Hello, everybody.
Sonia.
I introduce myself. My name is Sonia Castro. I work in the R&D department in Atos, Spain. Well, we've been all day long talking about network applications. We provided our vision as a project. We presented the network applications that we developed as part of the use cases, but I don't know if there are still doubts among the audience about what a network application is. If there are doubts, it's pretty normal because the network application is a novel concept that is a result of the virtualization of the networks. Elio was explaining this morning that network function virtualization is a key technology in 5G, and network application is just a result of the virtualization of the networks. As Daniele mentioned, there are several projects. I think there were 9 in total with us working. We have been working in the last 3 years on network applications, defining what network applications are, because the truth is that there is no a standard definition of network applications. Elio provided our view as a project, but the truth is that every project has a different view. Of course, there are similarities, synergies. We are encapsulating the application to remove the complexity of the networking for developers. We are splitting the application in pieces, so we are able to provide flexibility so we can deploy in different parts, in different areas of the network. But the way we encapsulate these applications differs from one project to others. So if the network application concept is adopted in the market, I guess we need a standardized definition of what a network application is. In the context of the software networks working group within the 5G PPP, we released 2 different white papers providing a general overview of all the approaches that the different projects have regarding network applications. So far, we weren't able to adopt a standard definition, but I guess this is something that we need to achieve in the future with maybe 6G, which is already coming while we are still defining 5G. So
thank you.
Thank you very much.
Thank you. Of course, all the volunteers have been saved by from preparing slides and presentations. So it's an easier way to go through a series of topics that could have been more complicated to put together. We mentioned 6G, but what's the difference between 6G and what we are doing in terms of, I don't know, network performances or what are we expecting from 6G?
Thank you, Daniele. This comes as a result of a discussion we had ad hoc last night with you. What I would like to highlight is, as Sonia started mentioning 6G, if we want to start thinking in terms of what comes next for smart grid networks, since we have shown here that 5G is useful and can help us towards wide area monitoring and the other applications. Based on that, ITUR has described under the framework of International Mobile Telecommunications 2030, a set of, not clearly defined, a set of network capabilities which can be described as 6G capabilities. Please keep in mind that there is no such thing now as clear boundaries for the 6G networks. From what I've searched, anything above 5G capabilities can be regarded as 6G, let's say, fulfillment. However, if somebody searches what the IMT 2030 framework, you will see that it's not only about enhancing KPIs such as peak data rate, spectrum efficiency, and latency. It is about enhancing such metrics, but it is also a matter of introducing newly capabilities. This could be the ubiquitous network coverage, sorry if I don't say it correctly, the sensing capabilities, localization, precision. So we must start thinking how these features can fit into the smart grids, smart 6G grid, let's say. Also concepts such as democratization of the network are considerably important, as some of us might have already faced under other SNS projects. It's very, very important to start thinking sustainability features, energy efficiency, and how the networks are accessible to all people. By all people, I mean people with disabilities, people with which cannot see clearly. These are very important so-called KPIs, key value indicators of the future networks. So we have to keep in mind that it's not only about network performance, speed, latency, and increasing this, but a more holistic view, let's call it impact towards the society. These are critical features that we have to introduce and consider.
Thank you. So what we learned is that 5G is not only about speed, is not one more number, what we see in the display. And what I think we demonstrate in the project at the end is that the technology is ready. So we started from a certain maturity of the technology. We were not sure while the core could have been made available by the end of the project, and still we don't have. I mean, the core in the infrastructure of the telco. But at this point, we want that technology. So the message is that technology is ready. TRL is quite high. A partial mitigation could be the blended implementation between 5G technology in the infrastructure together with the local platform. The other open point that was not investigated in this project, but it's a next challenge also for 5G, is the conversions. I can bring you the example of the Italian pilot. My colleagues from the technical back office told me that why can't we have this tool to monitor everything? Because we have a lot of mobile connection in 4G and optical fiber and other kind of media. So why not to have a comprehensive tool? The topic is not only about the tool, but something that is allowing more flexibility and more interaction between the mobile infrastructure and the physical infrastructure, and fostering really the distributed computation. So let's go through a series of final remarks. I don't know if there are any comments, any further observation before to close the roundtable, even because somebody told me that the table there is squared, so it's not that round. It's a joke. And it's not present, yes. It's a virtual, you know. After the virtualizing the coffee machine, we are virtualizing the table. But some final remarks about the project. So let's start with some numbers. So the project is divided in several work packages. We achieved, because this was the last one, the final event, 14 milestones. We are finalizing the last 12 out of 32 deliverables. The project has been working for 40 months. It has involved 24 partners with some changes, but at the end, we remained more or less the same. 4 linked third parties, 1 major external contributor, and thank you to be here today with us. Around 200 people involved. So even if in the meeting we are not that many, but I checked all the mailing lists and the contacts, we are almost 200 people working in the implementation. So this is the why we achieved all these results, because of the people. So one great team. Different knowledge domain, and as we also saw in this last round of conversation, by the time of the execution of the project, we learned a lot from each other, and it was complicated at the beginning to step over the perspective of each other, but people makes the difference, so thank you for that. Lots of constructive discussion, not fight, because it was discussion at the end. Okay, 7 countries involved, over 3 time zones. So thanks for the patience to Helio, who was the one from the most western side to adjust maybe to the Cyprus time zone. So these are the 2 extremes, but we are representing most of the countries in the Southern Europe, and we are finalizing the project in the Nordic somehow. 2 DSOs, 2 large DSOs, 1 wind farm involved, 2 university who gave a really great contribution to the implementation, 1 research foundation, 12 SMAs. That we were 13, but something happened. 7 platform components implemented, and 6 functionalities. 8 key exploitable results. For more details, the deliverable are almost there, so they will be published. 4 network application up and running. 9 5G PPP working groups. Number was correct. Thank you. 23 publications in either in articles and event and and the number is not consolidated, but this is the outcome from the last drafted deliverables. 99 presentations. So we all made a great job in talking about the project. 12 major events where we participated, and we organized or contributed to organize 20. 4 real-life 5G pilots in Italy, Spain, Bulgaria, and Greece. And here are the key features of the network application. So on the one hand, we are fostering the integration of the core network features. So the features are there, even if the core is not completely implemented, but with the network application, we can facilitate the integration. The orchestration and operation, so the network application through the network application controller that it's working together with the orchestration, we can also use and profit from centralized management, scalability and replicability, and leveraging on a flexible infrastructure. And last is the accelerating of the implementation. So providing a facilitation in the implementation of the network application conjugated with the automatic testing feature can also accelerate the access to this new, it's not new for the expert, but the virtualization paradigm. So these are the main outcomes that we kept promoting in all our presentations. So an open service repository as a single entry point for developers, automatic testing and validation framework, the VMV framework, the real-life demonstrator in a number of 4, a roadmap for third-party experimenter and engagement, a contact desk support that has been implemented and it was working, and also the cooperation with the ecosystem of the other 5G project, that yes, we tried to go towards a standard. There are still open discussion, and this will be the token to be managed by 6G in the upcoming cycle. So last but not least, the project has been founded by European Commission in the framework of Horizon 2020. It's one of the last working project for the 5G group. There is still one going. It will terminate in November. And next cycle of 6G projects are supported by Horizon Europe framework. Sorry, I'm starting to feel tired. So, last point is to say a big thank you to all the partners that cooperated to reach this achievement, and a big thank you from my side. So, thank you all.